Imagine you have a data of 60,000 people, and you have to predict the salary according to their experience and position manually. It would be a very difficult task. So we will use linear regression to solve this problem. In this video I will tell you what, why, when, how, limitations, assumptions, and what are the types of linear regression. Let's start with what is linear regression. Linear regression is a machine learning technique used for modeling and analyzing the relationship between a dependent variable and one or more independent variables for linear data. Goal to find the best fit linear equation, a straight line in simple linear regression or a hyperplane in multiple linear regression, that minimizes the difference between the predicted values and the actual observed values of the dependent variable. Linear regression equation is y equals beta 0 plus beta 1 into x plus epsilon, where y is dependent variable, x is independent variable, beta 0 is intercept of y when x is 0, beta 1 is slope, coefficient, change in y for a 1 unit change in x, epsilon is error term or residual. Why to use linear regression? First, prediction. You can use it to predict future values of the target variable based on historical data. Second, understanding relationships. It helps in understanding and quantifying the relationship between variables. Third, inference. It can be used to test hypotheses about the relationships between variables. Fourth, linear dependence. To find linear relationship between independent and dependent variable. When to use linear regression? You believe there is a linear relationship between the variables. You want to predict a continuous outcome. You have a data set with enough data points and predictors. You need a simple and interpretable model. How to use linear regression? Gather data, collect data on your target and predictor variables. Data preprocessing, clean and preprocess your data. Model selection, choose the appropriate type of linear regression, simple or multiple. Model training, fit the linear regression model to your data. Model evaluation, evaluate the model's performance using metrics like RMSE, R-squared, etc. Prediction, use the trained model to make predictions on new data. Limitations of linear regression. Linearity. If data is not linear in nature, it may lead to wrong predictions. Sensitive to outliers. Linear regression is sensitive to outliers, which are data points that significantly deviate from the general trend. Outliers can unduly influence the estimated coefficients and the model's predictions. Data quality. The quality of the data used for linear regression is critical. Missing data, outliers, or measurement errors can affect the model's performance. Limited feature engineering. Linear regression does not handle feature interactions or transformations automatically. Feature engineering may be required to capture complex relationships in the data. Model complexity. Linear regression may not perform well when the relationship between the predictors and the target variable is highly complex or when interactions between variables are important. Assumptions of linear regression. Linearity. The relationship between the independent variables, x, and the dependent variable, y, is assumed to be linear. Know a little multicollinearity. In multiple linear regression, with multiple predictor variables, the independent variables should not be highly correlated with each other. No autocorrelation. Autocorrelation occurs when the residuals are correlated with each other over time or across observations. Homogeneous. Data should come from homogeneous source. No perfect linearity. There should be no perfect linear relationship among the independent variables. Types of linear regression. Simple linear regression. This is the basic form of linear regression, involving a single independent variable, predictor, used to predict a continuous dependent variable, target. The relationship is represented by a straight line. Multiple linear regression. In this variant, multiple independent variables are used to predict the dependent variable. The relationship is represented as a linear combination of these predictors. Polynomial linear regression. Polynomial regression extends linear regression by introducing polynomial terms of the independent variables to capture nonlinear relationships. Here is the summary of what we have learned.